We're going to walk through a few more of these properties, and then we're going to look at solving at the end of the day. All right? So I asked you to do a couple of these. So on this one here, how did you start this one? This was kind of the warm-up. What does it need, or what do we need to do on this one to help me? The base is E. What do I do with this? I can put it out front. So this is square root of 3, natural log of E, which I like that. What is that? That cancel, that's 1. And so my answer here is just square root of 3. Okay?
How did you get that second E?
This one right here? That's my base.
Oh.
Okay, my base wasn't on there, so I included my base. And then I'm good to go. Alright? Now, before I get to this one, I want to do one other one quick. Alright, we skipped this one yesterday, but I'm going to work this one real quickly for you. Alright? 5, log base 5 of 18. Is this an exponential problem or a log problem?
Are you saying it's like 5 to the
Kind of
power
both.
all that?
It is 5 to the power of all that. It just so happens that the log is in the exponent. You with me? This is an exponential problem. Now, there is a shortcut on this one, but if you don't see it right now, let's do it the long way like we did yesterday. So if we said this is equal to x, what we said yesterday is if this is an exponential equation, we can add on the log. This is my base, so that 5 would go there. The other two values switch sides. So the x would go over here, and that whole value, which is log base 5 of 18, that is a number. I don't know what that number is. That is a number. It goes there. Well, if I have it written in log form, is it pretty easy now? Those two bases are the same, right? So therefore, x has to equal to 18. Yes. Yes. All right. So x would equal 18. Now, the shortcut on that is this. This base is 5, that base is 5. We have an exponent, we have a log. These essentially cancel each other out. And so the answer would just be 18 that way as well. Okay? All right. Hey, so we have this here. So that cancels. I can have that. All right. Now I did that because that's going to be helpful for us in this one. So this was one that I asked you to do as a warm up. Might not have been able to do all of that, but want to be able to look at it and see and go from there. So I'm going to ignore the 4 for right now. I want to see if I can get my exponent to be a little simpler. Okay? Anybody see something that I need to do first? I need to move this 2. All right? I can't combine these right now because they're not exactly like bases. They have to look exactly the same. So log 4 and log 4, but this one had a 2 in front, so I'm going to move it back. All right? So if I were to do that, I have 4 log base 4 of 6 plus log base 4 of 3, and that 2 got pushed back 3 squared. Okay? Now I can combine like terms. So this is log base 4, that's log base 4. There is a plus there. What can I do if there's a plus there? I can multiply. So I can go 4 log base 4 of, this is 6, this is technically what? 9. So I go 6 times 9, which would be 54. Thank you. All right? 6 times 9, which is 54. Now, if you notice, that looks like the problem that we just did on the previous page, right? I got a base of 4, I got an exponential, I got a log. So these cancel, and it gives me 54. So it's kind of hard to believe that all that we started with simplifies down to something that's nice and neat as 54, but it does. Okay? Yes?
How does 4 to the log base 4 cancel?
Well, you see how we wrote it as this right here a while ago, all right? And so basically what's going on is we're doing a log and an exponent with the same base, so they cancel. I'll do one, I'll show you here in a second. I'll kind of come back to it when we solve.
Wait, so
Alright.
how are we adding 6 and 3 squared? Are we multiplying?
We multiply that together. So our property from yesterday says if I'm adding logs, then I multiply those two big numbers.
And the base has to be the same.
The
So,
base has to be the same. That's
so
correct.
you can't have log and 2 log.
No, they have to be exactly the same.
Okay.
Alright, so here we go, let's try another one. So I've got log base 2 of 48 minus 1/3 log base 2 of 27. It's a little bit simpler than what we just did. Alright, do I have like bases? Yes, but do I have something else? The 1/3. I gotta fix the 1/3 first. So I'm gonna take the 1/3, I'm gonna push it back, and I do have log base 2 and log base 2. So log base 2 of what's gonna happen when I put the 48 and the 27 to the 1/3 together? It's gonna be divided. Since it's subtraction, I'm gonna divide. Okay? So I'm gonna take 48, and then this is gonna be 27 to the 1/3. What does it mean to take something to the 1/3 power? Cube root. That's right. I'm gonna cube root. What is the cube root of 27? 3. 3 times 3 times 3 is 27. So this is gonna be a 3 that's here. 27 to the 1/3 is 3. I did 48, since it was the subtraction, I divided. Alright, now, what is 48 divided by 3? 16. So this is log base 2 of 16. So I got it all down to 1. Now, could I keep going? The answer to a logarithm is what? The exponent. What is there an exponent that takes 2 and makes 16? 2 to the 4th, that's correct. 2 to the first is 2, to the second is 4, 2 cubed is 8, to the 4th is 16. So the answer here is 4.
It's a very interesting way of writing 4.
Yes, it is. All right. What I'd like for you to do on this one is I want you to simplify inside the parentheses. Do that part for me real quick. I've got natural log of 3 plus natural log of 6 minus natural log of 2. I want you to simplify that part real quick. Do I have like bases on all those? Yeah, the base is what? The base is E. That's correct. What am I going to do with the 3, the 6, and the 2? I'm going to multiply the 3 and the 6 together, then divide by 2. That's correct. So I'm going to go natural log of 3 times 6 divide by 2. That's what it's going to look like. 3 times 6 is 18, divided by 2 is 9. So this is natural log of 9 inside. That's what it looks like. I still have that 1/2 on the outside. What can I do with the 1/2? Distribute. I can push it back to where it came from. What does the 1/2 power mean? Square root. Do I know the square root of 9? 3. So if I push it back, it's natural log of 9 to the 1/2, which is 3. So this answer is just natural log of 3. Now, it didn't quite simplify as much as the previous one did, but it's pretty nice. It's pretty simple little log, all right? I don't know what the answer is. I'd have to type it in my calculator, but if it's non-calculator, that's what I'm gonna write right there. Just natural log of 3. I'm gonna move on. Okay? Questions on either of those two? Occasionally we want to take something like this, and it's been put together for us, and we want to kind of separate it back out to where it came from. So if I have natural log of x, y over z. So if I have natural log of x times y over z, and I want to write it where it came from. How would you get x times y? How might I get that?
Natural log of x.
Natural log of x plus natural log of y. That's how I'd get that. I'd multiply them together, but if I go the other way, I'm going to add them. What if I divide it by z? Minus natural log of z. There it is. Now I could kind of separate it out. I could solve for maybe x or solve for y, solve for z. I kind of pieced it back apart. All right? Give you a chance to copy this last one down here. Natural log of x times square root of x plus 1, or excuse me, 1 plus x squared. Could we take it apart a little bit? Okay? How could we take it apart? We could simplify the square root. How are you saying that?
Because wouldn't that just be 1 plus I?
Not quite. All right? Because that would be the sum of two squares.
Oh.
Okay, which we can't factor. I see what you're doing there. Not quite though. You can't quite do that. It's a good thought though. All right. I have a multiplication right here. So I have multiplication there, so I know I can take that apart by using addition. So natural log of x plus natural log of square root of 1 plus x squared. So I kind of got that pieced apart a little bit. Any other thoughts on this one? Can you rewrite this? Is that the same thing? Yeah. Now some of this, I don't know how far we would go, but it might say show that this is the expansion. We're going to have to prove it. Some of it's helpful for me when I solve, some of it doesn't. And the other thing I could do is I could take that 1/2 and put it out front. Okay? Some of that's helpful, some of that's not quite so helpful sometimes. All right? But that is how we can expand it, and we can use that to help us solve some things. If you get this property here, if you get log of m plus n, you can't expand that. You can't rewrite that. You can rewrite this. We did that a couple times already, but multiplication, we can rewrite that. Log of m plus log of n. All right, that would work. You could do this one, m divided by n. That would be subtraction over there, okay? But you can't break this apart right there. So don't get them confused. Make sure that you kind of have them sorted out. All right. We'll do a couple other little things real quick. And then we're going to go look at some solving. If I say this, x is equal to the log of 2, and y is equal to the log of 12. Excuse me, log of 6. The answer that I get is log of 3. Could you tell me how I got that in terms of x's and y's? X is log of 2. Y is log of 6. The answer that I came up with was log of 3. Can you tell me how I got there with my x's and y's?
Y divided by x.
Okay, y divided by x. You're close.
Y minus x?
It's y minus x. Okay? But you're on the right track there. Because what am I going to do with the 6 and the 2? I'm going to divide them. Okay? So I'm going to go log of 6 divided by 2. All right, I'm going to go log of 6 minus log of 2. If I did that, then I would divide the 6 and the 2 and I'd get 3. Well, what is log of 6? That is y. What is log of 2? That is x. So in terms of x's, we would say that is y minus, or in terms of y's and x's, that would be y minus x is how to get this. Okay? So what I want you to do is this. I want you to try this. How would you get log of 12? And how could you get log of 36? So two different problems. How could you use the same thing here? X is equal to this, y is equal to this. How could you get 12? How could you get 36?
How did you get 30?
I knew I'm going to have to do 6 divided by 2.
Oh,
Okay?
It's
So,
division,
but when I set my logs up, I'm going to go log of 6 minus log of 2, which means I'm going to divide the 6 and the 2 to get here.
okay.
All right? Because log of 6 is y, log of 2 is x, so it's y minus x.
So you want us to put it in terms of X and Y?
I need it in terms of x and y. Now, if you need to write it in the terms of the other ones first to get there, that's fine. Which one's the easy one? Hope you're going to say 12. How do you get 12?
Just by adding 6 and 2.
We're going to add them because what are we going to do with the 2 and the 6? We're going to multiply. So if you went log of 2 plus log of 6, then we'd multiply the 2 and the 6, and that would be the 12. Well, log of 2 is x, log of 6 is y, so we'd say x plus y.
Is
Okay.
36 just 2y?
Okay. 36 is 2y. That's one way to say that. Anybody else come up with a different way?
Could you put log 6 plus log 6?
You could do log 6 plus log 6 because then I would multiply the 6's together and get 36. What is log 6? Y. Log of 6 is y. You could say y plus y. Well, what is y plus y? 2y. How did you get the 2y that you said?
I first did it y plus y, and then I just.
Okay, and did that? Okay. Does that work? What do you do with the 2? Push it back, right? And now I got 6 squared. All right. But this is y. So 2y that way. So there, on these, there's not just one way of finding these. This is being a really, they like to use this from time to time, and that's kind of really creative, kind of outside the box and stuff as I'm going. Okay? All right. Here we go. Want you to take a look at this right here. We're going to solve some exponential equations now. Okay? Once you copy down 1 and 2, all right, we're not going to do 3 today. Hello? Hello? All right. We solved these last Friday. So we solved some exponential problems like this last Friday. All right? What do we need to be able to solve something like this? What do we have to do to solve this? We may need to use a log, but on this one I don't have to do it quite yet.
Make the bases.
I can make the bases the same. Can you make 3? My bases are not the same right now. I got 3 and 81. Can you make 81 be a base of 3? Yeah, we've been talking about it already a little bit today. It's 3 what? 3 to the 4th. 3 to the 4th is 81. Okay? So if I can make the bases the same, then I'll make the bases the same. Now the exponents have to be equal to each other. And then I'm going to solve that problem there. So minus 1, x would equal to 3. Okay? So I can do a lot of these by hand if I can make the bases the same. Now, we'll see on question 2, that's not going to be an option here. So let's take a look at question 2. What might be your first move on question 2? Multiply? Multiply what? Can't multiply the 8 and the 3. Why not? That one has an x and that one doesn't, right? If you distribute in there, then you're given an x to the 8, which it doesn't have. I do need to address the 8 though. What am I going to do with the 8 though? I'm going to divide by it. I'm going to get rid of it. Okay? So I'm going to go 3 to the x is equal to 5/8. what I'm trying to do is I'm trying to get a base and an exponent by itself. Okay? That's what I have. Now, do I have like bases? Can you make 5/8 be 3 or 3 be 5/8? Probably not very easily. You probably can, but I'm probably not going to do it. This is where I need to use my logs. Okay? And so I need to get the x by itself, so I need to get rid of this 3. I'm going to do log of 3 on that side right there. Just going to widen that out just a bit so it's easier. So I'm going to do a log of 3 on this side. Why did I choose to do log of 3?
So they cancel.
So they cancel. Alright, so that's going to be x. That's that property that we've been talking about. Well, if I do a log of 3 on that side, then I have to do the log of 3 on the other side. Okay? Now, that's going to be a calculator problem. I'm going to take that and put that in my calculator here in just a moment. Okay? Now, you're going, we could do this like we did yesterday as well. Yesterday, we took the 3 and we said, okay, add the 3, or add log, keep the 3, take the x and the 5/8 and switch them, and you get that. Is that the same thing? Same thing, right? So I did it kind of more mathematically there. The green is kind of the little algorithm that we did yesterday. So I'm going to go to my calculator. I'm going to go plug that in. I'm going to go control log, control 10 to the x. I'm going to put my 3 there. I'm going to put my 5 divided by 8 there. That's my 5/8. I'm going to hit enter. That's my answer. So my exponent is negative 0.428. All right? Everybody okay with that? All right? So we can see we can solve it by hand, or if we need to, we can use our logs to solve it. Okay? Let's try another one. I'm going to rewrite it because it's kind of hard to see. 500 e to the 0.3x is equal to 600. 500 e to the 0.3x is equal to 600. Okay?
Is there like a hidden natural log in there?
There is going to be a natural log involved. Correct. Okay? Where am I going to start, though, with this problem?
Add a base.
Get rid of the 500. How do I get rid of the 500? Divide. Okay? I'm going to divide by 500. So that's going to leave me e in 0.3x equals, I'm just going to cancel the zeros and say this is 6 over 5. You could leave it 500 or 600 over 500 if you like. Okay? You can write it 1.2. That's what it is. Okay? Now, I've got it to a base and an exponent. All right? I've got the base, I've got my exponent, but I'm stuck. Now, what am I going to do? Natural log. That's correct. I'm going to do the natural log on this side. I'm going to do the natural log on that side. Why did I choose natural log? Because the e's cancel. That cancels, gives me 0.3x equals natural log of 6/5. And I do have one last step in this one. What's my last step? Divide by 0.3. Okay? What I'm going to do is probably in those 2 separate steps, I'm going to do the green, all right? Then I'll come back and I'll do the red in my calculator. Okay? So this is definitely a calculator problem. You'll see this on the calculator part. All right? So if I were to do this, natural log, where's natural log on my calculator? Right next to log. It's the e to the x. All right? Control, e to the x. So I'm going to do 6 divided by 5, or 600 divided by 500. I'm going to get that answer, and then I'm going to divide that by 0.3. Okay? So my answer would be 0.608. 0.608. Now you're noticing these are not very pretty numbers right now. All right? We're needing our logs to help us to solve it. Couple more problems. Hang with me. You look like you're fading on me. X to the 1/3 minus 5 divided by 2 is equal to 7. your first move?
Multiply by 2.
Yeah, I'm going to get rid of the fraction. Multiply by 2. All right? So multiply by 2 here, multiply by 2 there. So x to the 1/3 minus 5 is equal to 14. Now what? Add 5. Does this problem look a little different? Where's my x? It's the base this time, it's not the exponent, right? So this is not an exponential equation. This is a power function is what we call this, okay? This is a power function. So do I need to use logs to solve it? Since it's not exponential, I'm not going to use logs. How would I get rid of that 1/3? That is cube root, that's what that means. So I'm going to do the opposite of cube root, which I'm going to cube it, okay? So I'm going to cube this side, and I'm going to cube that side. So that's going to give me x equals 19 cubed. If I did not have my calculator, that is exactly what I would leave, all right? I am not going to multiply 19 times 19 times 19, all right? Don't want you to worry about wasting your time doing that. Now, if I have my calculator, yeah, I can type it in. I can go get that, okay? Everybody okay with that one? All right. We'll handle 2 more. They're pretty quick ones. All right, here we go. Log base 3 of x plus 2 is equal to 4. So now we're going to go solve a log problem. Log base 3 of x plus 2 is equal to 4. Can I get rid of anything right now? Can I get rid of that 2? No, because it's inside the parentheses, right? If it was on the outside of the parentheses, then yes, I would. Okay? I'm stuck. If I'm stuck in log form, what do I need to do? Change to exponential. If I get stuck in log, change to exponential. We did this a bunch yesterday. The 3 stays. What goes right here? The 4 does. That is my missing exponent. That goes over there. And the x plus 2 goes to the other side. Keep the base. The other 2 switch, just like we did yesterday. Have we seen 3 to the 4th power today? 81. Hopefully that one you know now because we've seen it about 3 times. And now just subtract 2. So x is equal to 79. Okay? All right. Last problem of the day. Natural log of x plus 4 is equal to 2. Natural log of x plus 4 is equal to 2. What's your first move?
Get rid of 4.
We can get rid of 4 now, right? Why? Because it's not in parentheses. So we're going to get rid of the 4. So minus 4 minus 4. Natural log of x is equal to negative 2. We're going to do the switchy thing. Yes, we're going to switch forms. All right? I need a base there. Since it's natural log, it's got base e. I'm stuck in log form. I'm switching to exponential. So I'm going to keep the e. The negative 2 is going to go over here. And the x is going to go over there. That's it. That's my answer. All right? If it's non-calculator, I'd probably go on and say this would be 1 over e squared, just to fix the negative exponent. I'm not going to multiply the e squared out. I'm not going to go 2.718 times 2.718. Can I put that in the calculator if I want a decimal? For sure. Okay?
Could we
All right.
have left it if the 2 ended up being positive at the end?
Yeah, if this was a positive right there, sure, you can left it e squared.
But what about the 2 in black?
This one right there,
Like if that was positive, would that have been our answer?
that would have been our answer, yeah.
Okay.
Because it would have been positive. Okay? All right. On your homework, we're going to do the other 2 pages that we skipped last night. What is that, 415 and 416? Is that right? We're going to do those 2 pages. And then on page 420, we're going to just do question 1 and 2. We're going to save the others for the next night. Okay? So 415, 416, and then the 2 first questions on 420. Okay?
We get to keep our tests.
Yeah, you can keep that quiz.
No way.